My name is Catherine Mutica. I'm a PhD student. I'm in my final semester at Indiana State University. And I feel like the underdog here because I'm way down south compared to everybody else. But most of my PhD research has focused on things like food webs, biotic indicators, and macroinvertebrates all the way up to aquatic mammals. And so for my C grant, and I want to thank all of you, I appreciate it. I love funding. But for my C grant, I focused on that watershed that is just below Lake Michigan, so the Calumet-Galion watershed. So for this project, I'm also a teacher at Indiana State. So for our TAs, we teach as well. I designed a class that centered around this project. And so I took earth science majors, created a research project that introduced them to research using crayfish. And so my project was using crayfish as bioindicators for water quality. And most biotic indicators often, as soon as you begin to assess water quality, you use assemblages. So you start to look at several biotic indicators, and you move right away from the species level and you start looking at families, genus, and even sometimes orders when you look at things. Well, I've looked at crayfish throughout Indiana for about 2 years now, and I noticed that I was seeing species-specific responses to inorganic pollution, specifically to mercury. So for this project specifically, I began to really tease out this one organism biotic indicator that's species-specific. So preliminary data that I found, Indiana's kind of interesting. Rusty crayfish are native to the southern part of Indiana, but invasive in the upper part of Indiana. So I was able to use some historic data that I collected for native rusty crayfish and take a look at rusty crayfish in this upper area. So I wanted to use this one organism, species-specific, way to assess water quality. I wanted to look at mercury in crayfish to begin to see how mercury is moving through the food web. And then I also wanted to look at broader water quality in this northern area of Indiana. So our study area was here, this Calumet-Galion watershed. I'm not going to go too much into this because I'm preaching to the choir here. But I also wanted to show the areas that we've collected crayfish previously. So I focused on Faxonius, so riffle-dwelling crayfish. So I look at crayfish that are completely interacting with surface water. There's a couple of reasons I do that. First of all, I don't want to have an interference with groundwater pollutants and freshwater pollutants, surface water pollutants. But also, these are things that are easy to collect. They're an introductory species to science, and they're things that could be used for community outreach. So eventually, that's what I'd like to turn this project into, is a citizen science, BioBlitz type project that is easier for the community to understand. When you do macroinvertebrate assemblages, you're asking the community to understand 16 to 18 macroinvertebrates. But when you're looking at crayfish, you're asking them to understand maybe 11 different crayfish. And crayfish do not like each other. So when you are in a population area, you are only finding a specific species. So it would take you several feet to a mile down a creek before you would see a different species. So what was interesting is out of total that I've collected historically, I found about 8 species of crayfish throughout Indiana. But in this watershed area, we only found rusty crayfish. So Faxonius rusticus is invasive in this area, and we did not find any other crayfish. So we went to about 21 different sites, many of the sites weren't even habitable for rusty crayfish. So the area is still mostly affected by habitat loss rather than pollutants. So if you take a look at my overall map, I do want to point out that when it comes to mercury, all crayfish species, on average in a population, have more mercury than is allowable by NOAA, that 0.1 micrograms per gram. So all of the crayfish that I've collected, and I've probably collected thousands throughout the state. For this study, we collected about 211 crayfish. All of the crayfish in this watershed were over that 0.1 micrograms per gram. But the thing that's interesting is we began to see this species-specific response. So where rusties are in their native territory in the southern part of Indiana, you would see rusty crayfish carried a lower body burden for mercury than what you found in the sediments, floodplain, or even the water. So we definitely are seeing bioaccumulation, biomagnification, but that's expected. But what you see by species is different. So we did see a species-specific response. So rusty crayfish are here in the blue, and you can see they have a lower body burden, but it had higher mercury in the sediments and higher mercury in the floodplain, specifically compared to things like Faxonius virilis, which is a crayfish species that's indigenous to the entire state. They carry a higher body burden, but are able to live in these areas that have higher mercury in the sediments and floodplain and water. So they are pollution tolerant, just like rusty crayfish, but for some reason they're able to carry a higher body burden, whereas the rusty crayfish may have something physiologically that they are able to expel more mercury. You can flip. So this is actually a graduate student. So this, not only did this project support me, it actually supported 3 undergraduates. So they'll take what they did with the research and apply to NCUR to be able to present this research as well. And we also had 2 graduate students. Both of them were in their first semester, one a master's student, one a PhD student. The master's student has chose to research crayfish as well. She's looking at microplastics. That's her with me in Coffee Creek up in the northern part of the state. So like I said, what we saw for the most part is there's still impaired areas that crayfish are not able to populate, whether they're pollution tolerant or not. Things like channelized areas where the water is flowing quickly, it's very murky, and it's flowing straight along. Crayfish, rusty crayfish even don't like that type of environment. So my next steps are first to graduate, so I will defend my dissertation at the end of this month. So I need a job. Just gonna throw that out there in case anybody's interested in crayfish. I would like to continue research. In fact, I've applied for a couple of postdoc grants that would support myself, and I'd be able to stay at ISU and continue to research the crayfish. It's kind of a fun fact. My advisor is an oceanographer, so our only thing in common is biogeochemistry. And for the most part, when she sees me walking in the lab, she kind of goes the other way. She's inorganic substances, and I'm always bringing dead things in the lab. I would like to continue to look at invasive species. You know, a lot of times in rusty crayfish included, they believe they have this competitive edge because they're more aggressive, or they, you know, eat out the food source or things like that. And, you know, what we're seeing with this research is they actually may have some other things that are giving them a more competitive edge. And that's it. I just want to thank everybody. I also want to thank the person that came in with the Connect cup. So I'm also a deaf scientist. So I hear with a bone-anchored hearing aid on this side, and she came in with the cup that has the deaf sign for Connect. So you're my new best friend.